All right, the last video we started off by talking about where three lines intersect in the same point, they are said to be concurrent. And that point of intersection is their point of concurrency. And we used that in the last video to discuss when we had perpendicular bisectors of the sides of a triangle. So here I'm drawing the sides of a triangle. And what we talked about in the last video is we first found its midpoint, and then we had a perpendicular bisector to the side of a triangle. So there's our perpendicular. We know it's intersecting it in half. Right here we can say the midpoint is here. So we know we're intersecting it in half, and then it's going to be perpendicular to the line that we had. And then our last one, we can say that the midpoint was here. It's going to be perpendicular. So 1, 2, 3, 1, 2, 3. And it's going to be perpendicular bisector to the side of the triangle that we have. So this point where all three of those lines intersected was our circumcenter. And we know that that distance is the same to each of our vertices. So if we were to measure the distance from there to there, they would be the same. The distance from there to there would be the same. And then the distance from here to here would be the same. So that was a special traits that we learned last section. In this section, it's very similar, and there's one way that I'm going to try and help you guys remember this. In this section, now I'm going to make this a little bit bigger. Now we are going to be bisecting the angles, so it's not bisecting these sides. So now, if we have our three angle bisectors, so here we're bisecting all of our angles, and here we're bisecting all of our angles. So when we have three angle bisectors, that point of intersection, still our point of concurrency, is now going to be the same distance away from all of our sides. And remember, the way that we measure the distance from a point to a line is it needs to intersect as a right angle. It needs to be perpendicular. So this distance from P to any of the sides of our triangle will always be the same. That point P is now called our incenter. And unlike the circumcenter, the incenter is always inside of your triangle. 100%, it will always be inside of your triangle, regardless if it's a right triangle, regardless if it is an acute triangle or an obtuse triangle. All right. Now, the way that I used to help my class remember this in the past was that you would ask yourself a question: where are you bisecting? So, if you bisect the sides, then you are the same distance to the angles. Right? And then if you bisect the angles, you are the same distance to the sides. All right, so just remember, whatever you bisect, you're the same distance to the other thing. So when you bisect the sides, you're the same distance to the angles. When you bisect the angles, you're the same distance to the sides. And that was one of the ways I tried to help them remember. So whatever you bisect, it's always the same distance to the other thing. All right, now we're going to go ahead and do a couple examples. So our first example we're going to do is it says GE. So first off, it says, what doesn't tell us, but it gives us 2 arc marks, so we know that it's bisecting that angle, 3 arc marks, so we know it's bisecting that angle, and 1 arc mark. So we know that we have our angle bisector, and where they all intersect is our incenter. Right, now one might look at this and say, well, Mr. Spellman, all of these are right angles, so why isn't this the perpendicular bisector? Well, it doesn't tell us it falls in the middle. They don't give us tick marks to say that FB is congruent to CF. They don't give us tick marks to say CD is congruent to DA. So we know that we're bisecting our angles. And this point is our incenter. And when we bisect the angles, we are the same distance to all of our sides. So we can go in here and put 1 tick mark, 1 tick mark, and 1 tick mark. I know that those 3 distances has to be the same. So that means that GE is the same as GF. So if I want to solve for GD, I need to go ahead and set these two equal to each other. So GE is equal to GF. So 2x minus 7 is equal to x plus 4. I will subtract over the x, add over the 7. So we get x is equal to 11. Right now, we want to solve for GD. Now, it doesn't matter which one we plug it into because all three of those segments are congruent. So you can plug it into here if you want or into here. Since we don't have to multiply by plugging it into x plus 4, I'm going to plug it into there. So that means GD is also equal to x plus 4 because they are all equal to the same thing. And GD is equal to 11 plus 4, or GD is equal to 15. All right, so that is using our Incenter to solve a problem. Now remember, the way that we're going to finish these videos from now on is I'm going to give you a problem and you're going to work this out on your own. So here is your problem. You must give me this answer on Remind. All right, and when you answer these, since I gave you 2 questions, first say video 1 answer, and then say video 2 answer. All right, so I'm always going to leave this last question for you now to answer on your own, and then we'll discuss this in class, and we can see how you guys did. All right, so that is it for this video. And that's it for this section as well.